Okay, now we're doing from 182, 9-3, numbers 9 and 10. Now 9 corresponds to 49 in the textbook, and 10 corresponds to 57 in the textbook. So number 9, from the online work, says find the positive values of p for which the series converges, and n equals 1 to, the sum of n goes from 1 to infinity, of n over 5 plus n squared to the p power. So let's look at a couple of cases. If, first of all, p equals 1, what happens? We would have the sum as n goes from 1 to infinity of n over 5 plus n squared to the 1 power, which is just basically saying the sum as n goes from 1 to infinity of n over 5 plus n squared, like that. And I know that we having an n squared is not a problem in the denominator, except we have an n on top, and so essentially as n gets really big, that 5 becomes less and less relevant and becomes n over n, and it would be essentially 1 over n, which is our harmonic series. So this diverges like a harmonic series. Harmonic series. Okay. Now, the other case to look at is, what about the rest of it when p is not 1? Well, our f of x is just basically x then instead of n over 5 plus x squared to the p power. Again, p not equal to 1. And our first derivative is going to be what? Well, low d high, that's going to be 5 plus x squared times 1 minus high, which is x, times the derivative of the denominator. Excuse me. Oh, this should be p power here. And that's going to be p times 5 plus 2x, no, 5 plus x squared, excuse me, times 2x. So we have this power is p minus 1. So the power came down, subtract 1 from the power, and then the derivative of the 5 plus x squared is 2x. All over the square of what's below. That's 5 plus x squared to the p, and we square this amount. And this has the effect of saying f prime of x equals 5 plus x squared to the p minus x times p. Well, I should say x from here, x there. So we'll say 2x squared. 2x squared times p times 5 plus x squared to the p minus 1 over what? Well, we have 5 plus x squared to the p squared, so that becomes 5 plus x squared to the 2p. Remember we multiply powers? Now I have 5 plus x squared to the p and 5 plus x squared to the p minus 1, so we can reduce this so that f prime of x becomes, I can divide a p minus 1 out of the top and bottom. We still have a 5 plus x squared from the first term to the 1 minus 2x squared times p over 5 plus x squared to the 2p minus p minus 1 would be 2p plus 1. So what we had was 2p from the denominator minus p minus 1 from the numerator gives us 2p minus p plus 1. Okay, so it's just a p, not 2p. And we have p plus 1. Hopefully that makes sense. And we'd have f prime of x would equal basically 5 plus x squared minus 2x squared p, and the idea is I want to bring these x squared terms together, over 5 plus x squared to the p plus 1. And that's going to be 5 plus, you could say it's going to be 1 minus 2p times x squared over 5 plus x squared to the p plus 1. Okay. So for a p that's positive and p is not equal to 1, f prime of x will eventually be negative. I mean, it may not initially be negative, but p being positive, you're going to get a negative term from 1 minus the 2p as p gets bigger and bigger. So that means that f is positive, continuous, and with a negative first derivative eventually decreasing. So the integral from 1 to infinity of x over 5 plus x squared to the p dx equals one over x squared plus 5 to the p times 2 minus 2p from 1 to infinity. Now for p being positive, this converges. Or should I say bigger than 1? This converges. For p being between 0 and 1, it's going to diverge. And we already know that p being equal to 1, it diverges. So, from 1 to infinity is going to be the value of p for which it converges. Now let's go on to the next one, number 10. Okay, for number 10 it says let f be a positive, continuous, and not decreasing function for x being positive, x being greater than 1, such that there should be a sub n equals f of n. I couldn't do subscripts. Let me see, subscript a, whatever. If the series converges to s, then the remainder r sub n equals s minus s sub n is bounded by 0 is less than or equal to r sub n less than or equal to the integral from n to infinity of f of x dx. Use the result above to approximate the sum of the convergent series using the indicated number of terms. So the n going from 1 to infinity of 1 over n squared plus 1 for 10 times. 10 terms, I should say. Okay. So what does our s sub 10 look like? That's going to be, put 1 in here. 1 over 1 squared plus 1, that's 1/2. Put 2, 1 over 2 squared, that's 4 plus 1 is 5, 1/5. Put 3, 3 squared is 9, so it's going to be 1/10. Put 4, 4 squared is 16, so it's 1 over 17. 5, 5 squared is 25, so see a pattern yet? 26. Put 6, 6 squared is 36, so 1 over 37. 7 squared is 49, so it's 1 over 50. 8 squared is 64, so it's 1 over 65. 9 squared is 81, so it's 1 over 82. 10 squared is 101, so it's 1 over 101. That sum is approximately 0.9818. Now the next part of this asks for that remainder, or approximation of the error. So 0.9818 is less than or equal to, the sum as n goes from 1 to infinity of 1 over n squared plus 1, which is less than or equal to whatever we have on the high end. Plus what? What's that something going to be? Let's figure it out. Well, we know 0 is less than or equal to r sub 10 less than or equal to integral from n being 10 to infinity of 1 over x squared plus 1 dx. And that's, you may not remember this, but that's an arctan. So it's going to be arctan of x from 10 to infinity. And of course, arctan of infinity is going to give us pi over 2 and minus the arctan of 10. Make sure it's in radian mode. And that's going to give us approximately 0.0997. So we know that we have a range of values. The low end's 0.9818 less than or equal to our sum as n goes from 1 to infinity of 1 over n squared plus 1, which is less than or equal to 0.9818 plus that calculation we did, 0.997, which gives us a high end estimate of 1.0815. So we're between 0.9818 and 1.0815. Hope that helps.